Hi students, in this video I am trying to cover the synopsis as well as some numericals on the topic on the chapter Dual Nature of Radiation and Matter, and on the topics photons, photoelectric effect and matter wave, etc. Okay, so here we go. So we can see on the screen that few formulas and other things. Okay, so photon, when it comes to matter photon, energy of photon, that E is given by E is equal to h nu, and nu is nothing but c by lambda, and h value is 6.6 into 10 power minus 34 joule second. And if you convert this joule second as a unit to electron volts, then it will be 4.14 into 10 power minus 15 electron volts second. Okay, then again, if energy is in terms of electron volt, if suppose, okay, then hc by lambda we have to divide by that charge E, that's why, so that we'll get into electron volt. Finally your answer will be electron volt here. Okay, so if you multiply that h into c, and if you divide it by electron volt, okay, electron, so it approximately it is 12,375, but we are rounding off it to 12,400 for our simplification. And remember, it is possible only when you take the lambda in Armstrong. Okay, suppose if you get the lambda in nanometers while solving the numericals, according to that you have to change this number. Clear? Then mass of the proton, actually the rest mass of the photon is 0, but its effective mass is given by Einstein mass energy relation, that is E is equal to mc square, and E is also can be written as h nu, that we can see here. Okay, so if you want to find only m, so m is equal to E by c square. Okay, so that E is nothing but hc, and again c square as it is. So now nu is nothing but c by lambda, so c by lambda, if you substitute c get cancelled and only one c will remain and lambda will be remaining here. Then that is also known as kinetic mass of photon, right? Then when it comes to momentum mass is equal to, p is equal to m into v, mass into velocity. So here v is nothing but c, because light speed is c, given by c. So here m is substituted by this formula and c is as it is. So cc get cancelled, only one c will remain. So here this is the extended part of the formula. Okay, it's this varieties of equations you can use while solving the numerical. Then number of photons emitted, okay, per second, that is given by n is equal to p by e, that is p is power, e is energy of each photon, so power by h nu, or h nu can be written as c by lambda, so c by lambda to numerator, take it to numerator. Then intensity of light, so intensity of light is given by I is equal to E by AT, that is actually P by area. Intensity is power of the radiation by per unit area, but power, power is nothing but energy per time taken. So this is the formula, energy per time taken, and area is there as it is. Okay, now if we take this area for a sphere, so if r is the distance of a point source of a power p, then intensity is given by I is equal to p by 4 pi r square. So it means this I is inversely proportional to the square of the distance. So this is very important thing, because we can use this directly to solve many numericals or some kind of statement numericals and all, right? So then next we go with next topic, that is photoelectric effect. So we'll see the formulae on the photoelectric effect. So we know work function, that is minimum energy required for the electron to eject, okay, to be ejected. So work function is given by phi naught, or sometimes it is given by w or w naught. Okay, so this is nothing but h nu naught or hc by lambda naught, okay, in joules. Suppose if you want to keep this in electron volts, again hc by lambda E is nothing but 12,375, or it approximately it is also written as 12,400. okay, again the same thing, electron volt, right? So this is also energy, that's why this formula is same with the previous what we saw. Okay, now comes to Einstein photoelectric equation, that E is equal to, okay, this is E, energy, okay, of the photon is utilized by two ways, that is one is work function, and remaining part is kinetic energy. Basically the if this is the surface, the light which is coming, photon, saying E is equal to h nu energy, and this energy according to Einstein is utilized in two ways. One is to remove this electron, that is work function is required first of all, and the electron which is coming out further will move with certain velocity v. Okay, if it is moving, obviously it is having kinetic energy, so that is K maximum, or K, that is half mv square. Okay, so these things told by Einstein. So this is K maximum, this is what K maximum is. So here it is V maximum, right? So E is nothing but h nu, phi naught is nothing but h nu naught plus K maximum as it is, or K maximum is equal to this or this. Okay, and one more thing, for photoelectric studies, okay, experimental studies, in that one of the graph shows, okay, with the help of graph, stopping potential, okay, what we studied in the graph. So this effect of stopping potential on the kinetic energy or photocurrent. So here we can study this. E V naught is equal to K maximum, where V naught is stopping potential is electron, charge of electron, and the K maximum is simply kinetic energy maximum. Okay, so next we study a few formula on wave matter or matter wave. Okay, so we know de Broglie wave, that is the wave associated with moving particle, okay, or moving particle having wave with nothing but lambda is equal to h by p. P is momentum, so m into v. For photon, if you want to write this formula, lambda is equal to c by nu. Okay, so these are the things we actually derive, or some sort of a small mathematical derivation will be there in your theory, but here, since we are solving the concentrating on competitive exams, I'm just directly giving the formula, okay, instead of deriving. So you just need to know this, okay, you should remember these things, okay, to solve few numericals. So for electron, again h by root 2 m k, ek is nothing but kinetic energy. So again, just now we saw kinetic energy K maximum is nothing but E V naught, right? So E here also we can write, this is not velocity, V is not velocity, this is potential, okay. Vs can be written, or V naught can be written, as we saw in the previous condition. So here I just repeat the things. So here V naught, it is not a velocity, this is stopping potential, okay, the potential we apply to stop the electrons, okay, that is nothing but stopping potential. Now further, if you see again, for the simplified calculation, if you substitute h value 2 and m mass of the electron and the charge of the electron, only V is not known thing, because it dependent what is the input we are going to give, that value will be taken. So this comes around, if you want to keep this in Armstrong, then this is 12.27 divided by root of V. Suppose if you want to keep it in nanometer, that is 1.227 nanometer, okay, so that changes. Now for deuteron, now we saw proton and neutron. Now for deuteron, the formula will go like this, and please remember this, okay. And for alpha particle, this is the formula. For proton, this is the formula. And for energy of the thermal neutrons at ordinary temperature, okay, where E is equal to KT, K is the Boltzmann constant, and T is absolute temperature. For that, if you take a lambda value for that thermal neutrons at ordinary temperature, h divided by 2 root of 2m KT, very important, K is Boltzmann constant, we have value 1.38 into 10 power minus 23 joule per Kelvin, okay, and T is the absolute temperature. Okay, now let us try to solve some numericals on this chapter. Okay, so here we go. Okay, so the first question is like this. Please make a note of the question properly, right? Photoelectric effect is an example for, okay, so photoelectric effect is an example for what? Elastic collision, inelastic collision, two-dimensional collision, and oblique collision. So the answer is inelastic collision, okay, the answer is inelastic collision, because there is a loss of energy due to work. Whenever the work happens, when the photon strikes the metal surface, there is a work, and there it loses some energy, that's why it is inelastic collision. So for the first question, option B is the right answer. Next, okay, now next question, which of the following is incorrect statement? Okay, so look at the options properly, right? Okay, so mass exert no pressure, option A. Mass photon rest mass is 0, then option B is photon energy is h nu, none of the above. So here, you know, this just now we studied photon energy is h nu, E is equal to h nu, that is true. Rest mass of the photon is obviously 0, that is also true. None of the above, we'll see. But photon exerts no energy, is it true? We have to check with this, because since electromagnetic waves, okay, carries momentum, okay, carries energy and momentum, so it also exerts the pressure. Since it carries momentum, it's obviously it will exert a pressure. So this photon exert no pressure is the wrong statement. So option A is the wrong answer. So we have to take this. This is the right answer. I mean, incorrect statement as per the given statement. This is the wrong thing. That's why we have to select the right answer. That right answer is option A. Okay. Now next question. Going to next question. Photoelectric effect was first successfully explained by whom? So Planck, Hallwatch, Hertz and Einstein. So all these people have done some work on photoelectric effect, but it was successfully explained by whom? It was explained. Explanation is very important here. The keyword is explained, successfully explained. So Einstein is the person who explained the photoelectric effect successfully. So option D is the right answer. Now going to the next question. If the energy of the photon is increased by a factor of 4, then its momentum will be, okay, so this is very important. Option A does not change, okay, and option B decreases by the factor of 4, option C increases by the factor of 4, option D decreases by a factor of 2. We should see this. Okay, now you know this concept. Basically momentum P is equal to E by C. Okay, it indicates P is directly proportional to E. Momentum is directly proportional to energy. So if the energy of the photon is increased by the factor of 4, then the momentum obviously is directly proportional. Whatever the increase here, obviously this also increase. If it is 1, here also 1. So it is, if it is 4, then it is increased by 4. So option C is the right answer. Hope you got this. Option C is the right answer. Clear? Okay. Next, we'll move to the next question. Right? Okay. Look at the question properly. Read it. It's quite bigger. Now, a 200 watt sodium street lamp emits yellow light of wavelength 0.6 micrometer. Okay. Stop. Assuming it to be 25% efficient in converting electrical energy to light, the number of photons of yellow light is emitted per second is. Okay, so look at the question properly. Once again, read it, and you have to find the answer. Okay, you have to find n here, right? To find n, let us solve the thing. Okay, we'll find n now. So you can try your own meanwhile, right? Okay, so they had given power P. Okay, power P. So 200 watts they have given, but you have to convert, right? Because the percentage, that is 25% efficient means 25 by 100, right? So it comes to around 0 get cancelled to find 225, that is 50 watt, correct? So 50 watt is the power, and we know n, the formula power by E, right? This is the formula we have, but energy they are not given. So it is very important to find the energy here. So let us find the energy first. Okay, energy E is equal to h mu by lambda, right? Or directly we can solve it here. So power is anyway P, and if I take hc by lambda, then it is P into lambda divided by hc, correct? Right. So power P is 50, lambda they have given, no, lambda is it given? Yeah, 0.6 into 10 power minus 6 divided by h, 6.6 into 10 power minus 34 into 3 into 10 power 8, correct? So this is how we can do. Now suppose I have to calculate, right? So we'll do one thing, 3 into this, okay, so we'll keep this as it is, 50 into, I'll make this 6 into 10 power minus 7, because 0.6 is difficult to calculate, so 6 into, so this is 3 into 6.6 is 18.18 into 10 power minus 34 plus 8, that is minus 26, right? So now here, now suppose this, now we'll calculate, okay, this is 6 ones are 6 threes are and 6 threes are, so 3.3, so 50 divided by 3.3 into 10 power minus 7 and plus 26, okay, and it takes to numerator, that will be plus 19, correct? So now 50 divided by 3.3, so 50 by 3 is usually what, 50 by 3 is 15, correct? But again 3.3 is there, so approximately it is 15.15. if you take, then it is 10 power plus 19. So options we'll see, okay, here 6, 3 and 62, only this is the possible case, and here 10 power 19, so this comes 1.515 into 10 power 20, okay, so n is equal to this, so obviously this is the right answer, okay? So try to pick up the speed in calculation so that you'll get right answer in quick time. Fine, so we'll move to the next set of questions now. Okay, right, okay, look at this. Now we have the next question like this: photocell is a device to, okay, so options theoretical, it is not a numerical. So it is it a device to store photons, and or it is a measure, is it a device to measure the light intensity, or to convert the photon energy to mechanical energy, or to store the electrical energy for replacing storage batteries? Okay, so think properly and answer. So basically, actually, number of photons can be measured, which is directly proportional to the intensity of radiation. So photocell is basically used to measure the light intensity. Option B is the right answer. Okay, so next, moving to the next question. Looks very bigger one, but we'll see whether it is bigger or not. Okay, so when monochromatic radiation of intensity I falls on the metal surface, okay, so when monochromatic radiation of intensity I falls on the metal surface, the number of photoelectrons and their maximum kinetic energy are N and T. Okay, N and T means number of photons, photoelectrons are N, and maximum kinetic energy is given by T respectively. If the intensity of the radiation is 2I, okay, now initially only I was there, now they are changing, intensity is doubled, okay, 2I, then the number of photons emitted, number of emitted electrons and their kinetic energy are respectively what? So this is very important. So here you should know the fact that the number of photo electrons are directly proportional to the intensity I, okay, but K maximum is independent on intensity, okay, independent of I, intensity. So number of photons are directly proportional to the intensity. It means if intensity is doubled, photoelectrons are also doubled, but kinetic energy is independent, it will not be doubled. So only the photoelectrons will double, but the intensity will be same. It means number of photoelectron, number n will be changed but t will be same. It means 2n. So if I is becoming 2i, then so I and n are proportional, so this will become 2 and this will become remain same. So option B is the right answer. Clear? And moving to the next question. So if wavelength of photon and electron is same, then the ratio of total energy of electron to total energy of photon would be. Okay, so here what they are asking is the ratio. Okay, ratio we have to find it out now. We'll solve it. Meanwhile you can try by your own, right? So we know that E is equal to h nu is nothing but hc by lambda, correct? It means E is proportional to c. Energy is directly proportional to the c, or it is like velocity, correct? Energy is directly proportional to velocity. That is, energy of electron by energy by proton is directly proportional to EV by EP, because V is the velocity of electron, V is the velocity of proton here, Vp. Okay, now if electron velocity will remain to be same, and proton velocity is nothing but light, because a proton is nothing but light. Okay, so photon, sorry, it is P is not proton, it is photon, right? Photon, Vp. Okay, because here they are taking the photon, right? So here I should write photon velocity is c, correct? So it means E, that is energy of electron by energy of proton. We want to take the ratio. This ratio will be velocity of electron by velocity of velocity of light. So which is the right option here in the given? Look at the question properly. So in the given options, option A is the right answer, right? Fine, no doubt, I think. Fine. So with this I'm going to stop this video. Remaining question we are going to solve in the next video. Thank you very much.